In Module 2, Section 5, we're going to discuss multiplying and dividing real numbers. The product, remember product is the multiplication, the product of two numbers with the same sign is a positive number. Those two signs can both be positive, they can both be negative, but the result will be a positive number. The product of two numbers with different signs is a negative number. Let's try a few examples. Example A, we are multiplying a positive 4 and a negative 2. You'll see that those have different signs, so the product will be negative. Once we decide the sign of the product, we simply multiply the two numbers together. 4 times 2 is 8. Because the signs are different, the product is negative 8. Example B, we are multiplying negative 7 and negative 5. Both of these numbers have the same sign. They're both a negative. So the result will be a positive, and we wouldn't write the positive in the answer box, but just to denote we have a positive number, we're going to put the plus sign here. We will have a positive 7 times 5 is 35, or just 35. For part C, we have a positive 9 and a negative 6.2. Because these numbers have a different sign, the answer will have a negative sign. So negative 9 times 6.2 is 55.8. So the result, the product will be negative 55.8. On example D, although we are dealing with fractions, we still think of one fraction as being one number, another fraction as being a second number. And here we see that the first fraction, 3/4, is negative. The second fraction, 1/7, is positive. Because they have different signs, the product will be negative. We will still multiply the fractions just as we have in previous sections. Multiply the numerators, which gives us 3. Multiply the denominators, which gives us 28. And the product will be negative 3 over 28. Some special products that you might see when you're multiplying real numbers are products involving 0. So if B is any real number, positive or negative, and we multiply B by 0, the product is 0. So any real number times 0 equals 0. Here's an example. We have 9 times 0 times negative 5. Using the order of operations, when we have multiple instances of multiplication, we start from left to right. So we start with 9 times 0. Using the property we just discussed, 9 times 0 is 0. Now we work the last instance of multiplication. We have 0 times negative 5. And 0 times any number, positive or negative, will still be 0. So when your product involves 0, it doesn't matter how many other numbers or what numbers are involved, the product will always be 0. Remember, since repeated multiplication can be represented by using exponents, it makes sense to discuss using exponents with negative bases at this point. Remember, the base is the number that's being raised to the exponent. In example A, the number that is being raised to the exponent is negative 2. So that is the number that's being repeated. We're repeating the multiplication of negative 2 4 times. Now, one quick trick you can use to determine whether your product will be positive or negative is to count the number of negative signs that you're multiplying together. If the number of negative signs is an even number, then you will have a positive product. If the number of negative signs is an odd number, you will have a negative product. So here we can count. We have 1, 2, 3, 4 negative signs. 4 is an even number, so we will have a positive product. Again, we wouldn't write a plus sign as an answer or with the answer, but just to denote a positive number, I'm going to write the plus sign here. And then we will multiply the magnitudes. 2 times 2 times 2 times 2. Working that in your head or in the calculator, you would determine that is 16. And instead of writing the plus sign, let's simply write 16. Now, B is somewhat different than A. You might notice that on A, the negative 2 is contained in parentheses. And on example B, the -7 is not contained in parentheses. Because of this, the base is not the same. The base is not -7 in this case. Another way we can think of this expression would be -1 times 7 squared. The exponent 2 is not being applied to the negative whatsoever. And that's very important because that means we only have one negative sign. And if we are counting negatives, we want to make sure we have the right number of negatives so that we have the proper sign at the end product. So rewriting -7 squared is -1 times 7 squared. We can now rewrite this as -1 times, we have repeated multiplication of 7. 7 is being multiplied 2 times. Again, we can either multiply from left to right to determine the end sign, or we can count the number of negatives. In this example, we have one negative sign. 1 is an odd number. An odd number of negatives will give you a negative product. Once we've decided the end result, the sign of the end result, we can multiply the magnitudes of our numbers together. So you're multiplying 1 times 7 times 7, and you would determine that as 49. So the result we've already decided will be negative, thus it will be -49. Now, just like speaking about opposites and additive inverses, now it makes sense to discuss reciprocals or multiplicative inverses now that we are speaking about multiplying and dividing real numbers. When we have two numbers whose product is 1, they are called reciprocals or multiplicative inverses of one another. The only number that does not have a reciprocal is the number 0. The only real number without a reciprocal is the number 0. So let's find the reciprocal of the following examples. We will go through the process and use the definition to find the reciprocal of example A, and then we'll use a shortcut for B and C. For A, we want to determine what we should multiply 55 by in order to have a product of 1. So the first thing I would do is change 55 to a fraction. Then I would multiply by another fraction so that I would have 1 over 1, or just 1. Now, a quick way to determine the fraction we should multiply by, we need something that will cancel the 55. If we have 55 in the numerator, we will need 55 in the denominator. Since we have 1 in the original denominator, we will want 1 in the new numerator. When we multiply these two values, 55 times 1 is 55. Multiplying the denominators, 1 times 55 is also 55. When we simplify this fraction, we would start by writing the prime factorization of both top and bottom, which we see is identical. The 5's cancel, the 11's cancel. And when everything cancels, or when you divide a number by itself, it becomes 1. So because the product of 55 and 1 over 55 is 1, the reciprocal of 55 is 1 over 55. We say all that to say, anytime we're looking for a reciprocal, we essentially just want to flip our number over. Whatever the denominator of the original will become the numerator of the reciprocal. The numerator of the original will become the denominator of the reciprocal. So for part B, the reciprocal of -3 over 7 is -7 over 3. It is important to note the sign does not change if we are looking for the reciprocal. The sign does change if we are looking for the opposite, but not the reciprocal. And for part C, the reciprocal of 1 over 10 would be 10 over 1, or simply 10. Remember, when we divide by 1, it does not change the numerator whatsoever. So 10 over 1 is the same thing as 10. Now that we've discussed reciprocals, let's talk about what it means to divide real numbers and the process we will go through to determine if the result is positive or negative. The quotient of two numbers with the same sign, both positive or both negative, is a positive number. The quotient of two numbers with different signs is a negative number. Let's try a few examples. Example A, we have negative 20 divided by negative 4. Because both of these numbers are negative, the result will be a positive value. We then divide the magnitudes. 20 divided by 4 is 5. So positive 5 or just 5. For example B, we have positive 36 divided by negative 3. Because these values have different signs, the quotient, the result, will be a negative value. We then divide the magnitudes. 36 divided by 3 is 12. So the answer for 36 divided by negative 3 is negative 12. The same is true with fractions. We have a positive 7/3 divided by a negative 5/6. So remember, when you divide fractions, the first fraction stays the same. The operation changes to multiplication. The second fraction flips, or we multiply by the reciprocal. Now we multiply the numerators together and the denominators together. 7 times negative 6, they have different signs. So the answer is negative, negative 42. 3 times 5, they have the same sign, so that's positive, positive 15. But anytime we have a fraction, we need to make sure it's written in lowest terms, in simplest terms. So we start by writing the prime factorization of numerator and denominator. While doing that, I'm just going to put the negative out front and not include it with the numerator or the denominator. It just represents that the fraction is negative. The prime factorization of 42 is 2 times 3 times 7. The prime factorization of 15 is 3 times 5. We have a common factor of 3 that cancels. When we multiply the factors back out, we determine that the lowest term of this fraction is negative 14 over 5. Just a quick reminder and refresher, anytime we have 0 divided by a number that's not 0, then 0 will be the result. And anytime you have a non-zero number divided by 0, the answer is undefined. So for this reason, 5 divided by 0 would be undefined, because we're dividing by 0. 0 divided by anything, or in this case, 0 divided by negative 9, is simply 0. So anytime we divide by 0, it's undefined. Anytime we take 0 divided by a number, the answer is 0. Now the last definition you see on this page means nothing more than if you have a negative sign in the denominator, that's the same as having one negative sign in the numerator, or the same as putting the negative sign out front. As long as we only have one negative sign, we can write it on bottom, on top, or in front. And all of those are equal. All of those are the same. It's okay to write those however we choose. Let's try a few more examples just to practice multiplying positive and negative numbers and dividing positive and negative numbers, but now using order of operations. In example A, we have 7 times negative 9 plus 2 times negative 6. So using order of operations, and I'll write our acronym again. Hopefully you know what all of these letters stand for by now. We don't have any parentheses, so to speak. At least we don't have operations inside of parentheses or grouping symbols. We have no exponential expressions. We do have multiplication. We have 2 instances, 7 times negative 9 and 2 times negative 6. So we go left to right. 7 times negative 9 is negative 63. We have different signs. When we multiply those, it gives us a negative value. Now we have addition and multiplication. We still work the multiplication first. That gives us negative 63 plus 2 times negative 6 is negative 12. And now we add negative 63 and negative 12. They have the same sign, so we add the absolute values, and we keep the original sign. The answer is negative 75. For part B, we have 8 minus 3 times negative 2, all divided by, that's what the fraction bar stands for, negative 9 minus 2 times negative 3. Let's rewrite this, treating the fraction bar like a grouping symbol. So I'm going to put everything that was in the numerator in one set of square brackets, and everything that was in the denominator in another set of square brackets. And we're going to put the division operation in between those two sets of square brackets. So in this case, going through our order of operations, we do have grouping symbols. And when we have multiple grouping symbols that are not nested within one another, we'll just work those from left to right. So starting with 8 minus 3 times negative 2, we have subtraction and multiplication. So we will start with the multiplication. 8 minus 3 times negative 2 is negative 6. Everything else stays exactly the same. Still working with this first set of grouping symbols, we have 8 minus negative 6. Using our shortcut, that's the same as 8 plus positive 6, or just 8 plus 6, which is 14. Now going to the next set of grouping symbols, we deal with this, the multiplication first, not the subtraction. So we have 14 divided by negative 9 minus 2 times negative 3 is negative 6. Again, because we are subtracting a negative, that's the same thing as adding a positive. Draw an arrow because we're running out of room. We now add the two values inside of the grouping symbols. Negative 9 plus 6 is negative 3. Now, because this doesn't work out perfectly, 14 divided by negative 3, I'm going to rewrite this as a fraction. 14 divided by, or 14 over negative 3, which is the same as negative 14 thirds. The negative sign can go on bottom, it can go out front, it can go on top. I like to write my negative sign in the numerator or in front of the fraction. Whatever you prefer will be fine. But since we started in fractional notation, let's make sure we end there as well. That's the last example for this section. Make sure to work hard, ask questions when you have them, and do the best that you can.